What's up, guys? In this video, what I want to do is just cover verifying some basic trigonometric identities. So typically when we start off the lesson with trigonometric identities, which can be very confusing very quickly, I always like to go over some basic identities just to kind of get the idea of exactly what we're trying to achieve and how we can approach each and every one of these problems. Because one of the tough things about verifying trigonometric identities is what you do for one problem might not be what you're going to do for another problem. So it's really important to kind of practice as many examples as you possibly can, and also practice some very basic identities so you can see this relationship between the identities and our algebraic operations. So in this first example, you can see I have the tangent of a negative x times the sine of x equals negative cosine of x. Now remember, when we're verifying identity, basically what we want to do is we want to make one side look like the other side. So all we're simply going to do is pick a side, usually the most complicated, and you can see in this case on the left hand side I have two functions being multiplied, whereas this side I only have one. So it's going to be a lot easier to simplify these two functions down to one rather than taking cosine and then rewriting it as a cotangent of negative x times sine of x, right? What I want to do is think about how can I simplify this left hand side. So we're just going to focus on one side at a time. I'm just going to work on the left hand side and think about what are some things that I can do to this left hand side. Now, one of the first things I recognize here is this negative x, and when I see that negative x, a lot of times I tell students like a little ring in the bell, like ding 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 ding. Whenever you see a trigonometric function of a negative variable, think your even odd identities. And these are some identities that it's very important for you to kind of review and make sure that you have a good grasp on. So the cotangent of negative x is actually equal to a negative cotangent of x, which we can just again multiply by sine of x. Since I'm not dealing with a negative x, I'm not going to use parentheses here anymore. And again, we could also think about this as a negative cotangent of x as a negative 1 times cotangent of x. So now we're looking on the left hand side, and what we got to think about is how can we simplify this left hand side so it's just going to be a cosine. And the most common way that we're going to want to look into doing that is what we call the division property. So remember the division property. If I had like 3 divided by 3, that equals 1. If I had x plus 3 divided by x plus 3, that's equal to 1, right? If you have the cosine of 3 divided by the cosine of 3, guess what that equals to? 1. So whenever you have the same term, expression, or function of the same argument in the numerator and the denominator, then we can go ahead and divide them out. Now it's important that only works when terms are separated by multiplication, but we're keeping things simple in this example. So what I need to know is what identities can I use to rewrite my cotangent and my sine, so therefore I'm going to have some numerators and denominators. Now this is where a lot of students get stuck, especially when they're first learning their trigonometric identities, because they don't know which one should we choose. So let's go and write out all the different ways we can rewrite cotangent and sine using a fraction. Okay, so in this first example, you can see cotangent of x equals cosine of x over sine of x. That's the quotient identity. But also, I could also write cotangent of x as 1 over a tangent of x, right? That's the reciprocal identity. Or I could rewrite sine as 1 over cosecant of x, which is also the reciprocal identity. So what we need to do is we need to make a decision on something where we can rewrite one or both these expressions. So therefore, something's going to divide out, but I'm going to be left with just a cosine, right? I already got the negative that I wanted. Now I just need to figure out, well, how can I maybe have something divide out so I'm just left with a cosine? So hopefully you recognize here, if I use cotangent of x equals cosine of x over sine of x, that's going to put a sine of x in my denominator, which will now divide out with this sine of x here, because technically you could rewrite that in the numerator. So let's go ahead and rewrite the cotangent of x as cosine of x sine of x. Okay, you don't really need to put the 1 here, but I just wanted to make sure you understand that when I'm rewriting this as a sine of x in the denominator, cosine of x in the numerator, that this is really a sine of x over 1. And again, since my terms are separated by multiplication and I have the exact same function in the numerator and the denominator, guess what? They are going to divide out. Therefore, I'll have a negative 1 times cosine of x divided by 1, which is just equal to a negative cosine of x, which is now equal to the right-hand side. Now in this example, we can see all we have is on one side is trigonometric functions and on the other side is a number. So definitely we're going to want to work on the left-hand side again to make this see how can we simplify these down to be in a number. Now initially what my brain's going to is whenever something divided by itself, that's going to equal 1. So again, that's my thought process at looking at this problem. If I want this to get to 1, I'm going to want to get something to be divided by itself. Now unfortunately in this problem it does not look like anything is being divided by itself. It actually looks pretty confusing. I have the secant of pi halves minus alpha times the sine of alpha. And a lot of students will see this pi halves minus alpha and they just automatically get confused because It just, it's more of an expression inside the argument. But again, kind of going back to those, when you see a negative argument inside of a trigonometric function, think of like that ding, 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 ding. It's a cofunction identity. Cofunction identities are very important for you to be able to recognize and also to remember. So first thing I'm going to do is rewrite this with my cofunction identity. So the secant of pi halves minus alpha is actually going to be equal to the cosecant of alpha. Now remember, when I want to look into something being divided by itself, hopefully you recognize that cosecant and sine are reciprocals of each other. So therefore the product of a reciprocal times a reciprocal, for instance, like 3 over 4 times 4 over 3, that's going to equal a 12 over 12, which is just equal to a 1. Right? But maybe it's not apparent that these are going to be reciprocals of each other. So let's just go back to our reciprocal identities. So therefore you can see exactly how this is going to work. So here you can see the cosecant of alpha is 1 over sine of alpha, and the sine of alpha is 1 over cosecant of alpha. Now, one mistake that I will see students make is they'll apply both identities to both functions. We don't want to do that because, again, remember our goal, guys. We're trying to get something to be divided by itself. So I don't want to rewrite a cosecant of alpha as a 1 over sine of alpha, and then the sine of alpha as a 1 over cosecant of alpha. Because, again, it does not get something in the numerator, something in the denominator, right? So we don't want to do this. So again, there's nothing mathematically wrong with it, but it's just not what we want to do. So let me just go ahead and put it down from there. Don't really need to have the not equals because it is equal. It's just not true. So what I'm going to do is just going to take my cosecant of alpha and just rewrite that as a 1 over sine of alpha. So therefore there'll be 1 over sine of alpha times a sine of alpha. And again, you can rewrite this as 1 just so we can see that these are going to divide out into a 1. And therefore we're left with a 1 over 1, which is just equal to a 1. Now in this last example, it's much more confusing. We actually have an addition and division going on rather than just straight up multiplication. And we don't have any initial identities that we recognize, like the cofunction or even odd identities that we have to apply. In this case, what we want to do is rely on our algebraic operations. One of the key things I see students do it immediately from here is they say, oh, well, we've been dividing things out, right? I need a 1. So cosine of theta divided by cosine of theta, that just divides out into 1. We have to rely on our trigonometric operations. And even though this is division, and the identity that I want to actually look into is the distributive property. So if I have A times B plus C, it's important to remember that this A is going to distribute to both of my B times C inside of the parentheses, right? That's going to leave me with an AB plus an AC. Well, guess what? The exact same thing works for division. If I have a B plus C all divided by A, this A gets divided into the B as well as the A divides into the C. So another way to kind of look at this is, what if I had like some fractions? Let's say like a 1/5 plus a 3/5. Now again, remember, as long as the denominator is the same, you just add the numerators, right? So this is technically a 1 plus 3 over 5, which we can see is a 4/5. But again, what I want you to be able to see here, from this example, I can go to the right, which is simplifying, or I could actually like separate it out, right? So if I have 1 plus 3 divided by 5, I can also rewrite that as a 1/5 plus a 3/5. But notice how both of the terms in the numerator got divided by the 5. Right? So you can look at it algebraically, or you can look at it with an example. And the reason why this is so important is because what I'll see students do time and time again is they'll just divide out the cosines and they'll be left with a 1 plus a sine of theta. And then they say, oh, this does not work. It is not an identity. While some of the logic is correct, you can see that algebraically, they're not dividing the cosine properly. So what we want to do is actually rewrite this with the cosine being divided into both terms of my numerator. Now, hopefully you recognize whenever I have a trigonometric function over a trigonometric function that are exactly the same, that's just going to equal 1. Then sine of theta over cosine of theta is just going to equal a tangent of theta, which is now equal to the right-hand side. There you go, ladies and gentlemen. Hope this video was helpful. If you want more examples on verifying trigonometric identities, check out the examples and resources I have for you down below, or check out the next video I have for you here.